Gentlemen, that brings us to the ultimate speaker, the final speaker, sorry, not the ultimate, perhaps the ultimate, of India Arc Dialogues 2018. I had prepared an introductory note, but he stepped up to me during the break and said, just cut it short. So please put your hands together for Shajay Bhooshan from Zaha Hadid Architects.
Hello. So firstly, I'd like to thank everyone for staying on for this last talk, and many thanks to the curators for giving me an opportunity to speak. And it's great to come back to the city I studied in close to 15 years ago now. So as I told Madhav, like I'll try and introduce myself like as I speak through the talk. I have a few disclaimers and provocations to make ahead of time. Most of the disclaimers come from prior experience of speaking in various parts, and I'm trying to preempt some of the kind of thinking that like or questions that might arise because of like what I might have to say. So the main thing that I would like to focus on is that the future is indeed in a global hive mind. And the future is machine augmented, meaning humans who are augmented by the power and the diligence of machines, and it is indeed human focused. So it's not like AI or machines taking over, it is helping us be better designers. And also, I would like to provoke like this conversation relation between architecture and images. To say that the future is being produced at petabytes a second. Every smartphone is like gathering images, and most of it, we don't have to worry about like how redundant it is or how banal it is, because evolution will take care of all that is not vital for us. So the main thrust of the talk is basically to say that images is the first step to make architecture consumable by the users of the building or users of architecture. And so in that sense, like I would like to quote like Patrick Schumacher, who's the principal at like Zaha Hadid Architects since Zaha's passing last year and a half ago, that beauty is the promise of performance, and it's emphasis on the promise. You can break the promise, but in that sense, it is consumed visually first and primarily. And it's also a shortcut to calculation, so you don't have to compute or you don't have to calculate whether something is performing if you train your aesthetic and if you train your sense of beauty to already recognize that which is vital for you. So the talk in that sense is going to talk about a cumulative and collaborative and hopefully disruptive paradigm of inquiry. It's about an architecture that strives to make its visual consumption harmonious. Like, in other words, make it easy to be consumed visually first and before other senses could be engaged. Just by way of introduction, like I try to pursue like a lot of the research that I do for the company. The team that I lead is about like 11 people. Now we grow at 1 person a year. But I've been teaching at the AADRL, which is a design research postgraduate course, for close to 12 years now. And I've been working as a co-founder and head of Zaha Hadid Computation and Design Group, which is a research group, for the last decade. And also I pursue my technical education via a PhD now at ETH in Switzerland through Block Research Group. What the AA kind of was one of the first places it kind of highlighted to me that architecture is not about heroics or a single person anymore. Like that was the 20th century. And more architecture is going to be this. It is going to be cumulative, it's going to be collaborative, it is going to be in the hive mind. And what Zaha Hadid Architects kind of gave me insight into how waves of young people joined the office, and Zaha made the kind of environment possible for these kind of young people to be given responsibilities for like seminal buildings like the Maxi, which people who join at like the age of 25 or 26, over by the time they're like 33 or 34, have produced like one of a kind of seminal piece of architecture. And you can therefore see waves of work is like, whilst it might share the kind of title of Zaha Hadid architects, like they're clearly different because it's a different group of young people coming in, building their supplier network, building their collaborators, building their ideas, building their tool chains, building their software, etc., to deliver what are unique buildings. And what my technical pursuits at the ETH, specifically with the block research group, kind of gave me insight into what I always loved, computer graphics and computer games, that somehow they're magically linked to ancient history and like the building of cathedrals and stone masonry and things like this. And these three are not like nameless institutions for me. Like I've been very, very fortunate to be kind of personally guided through these institutions by the director of Theo Spiropoulos, who's the director of the DRL, and Patrick Schumacher at Zaha Hadid, and also Philippe Bloch, who's professor and director of the NCCR in Switzerland. So through one of the main things that I gathered from Theo is this idea of working with material, the idea of techne, the idea of expressing and relinquishing control, or doing just that little bit to be able to guide material through craft and through allowing the material its freedom to express itself. And Patrick is an analytical thinker, is like kind of exposed me to kind of a lot of critical thinking, that analytical philosophy particularly, that leads to philosophers like Daniel Dennett and connects them magically to more computer science oriented people like Claude Shannon, like the father of let's say information theory. And at the ETH, like professors like Olga Sorkin, like that kind of made mathematics and geometry like really fun things to learn and not a burden and to be endured. So I'm going to constantly refer to a we because it's like I can't claim to have done anything on my own. By we, I can mean like my partner in many crimes, like my wife as well, Alicia, the students of the DRL, where I teach now with Alicia, and colleagues and collaborators of Zaha Hadid Code and Zaha Hadid Architects, colleagues and collaborators of Block Research Group at the ETH. So to briefly situate like what I mean by this cumulative practice and what I hope is at the cusp of becoming disruptive, I'll briefly situate like these terms of production and consumption of architecture as well. What we mean by like disruptive is when the revolutionary things go mainstream. So, for example, the Ford Model A was a revolutionary car. It was the first model that Henry Ford kind of put out, like, and he managed to sell 2,000 cars, and like this was the forerunner for Ford Model T that sold 15 million cars. But a lot of the revolutionary innovations were already made in the Ford Model A. But nonetheless, both it would have amounted to nothing if, like, they had not taken the next step to try and deliver revolutionary gains that the discipline had made at the time, or the industry had made that time to the masses. So there's always a motivation for us to go through revolutionary phases, but then follow it up with like trying to deliver that to mainstream as much as possible. The other aspect that I would like to talk about is this focus that architects generally tend to have on the production side of things, material, structure, and all the physical things. But for some things to be successful, like the Ford Model T, like, you know, it also needs us to understand the consumption of that as a product, as a user experience, as a user interface, so on and so forth. And this is where, like, I believe that the image aspect, the visual consumption of it, really comes to bear, because we as human beings are very, very powerful in our abilities to process images. Like most of our brain is hardwired to process images and before other senses. So these are like the kind of physical production side, and also the social consumption side is what I will try and talk about and in this relationship. And lastly, trying to situate what I mean by cumulative and collaborative. I'm not trying to be politely inclusive. I'm trying to follow a line of thought that comes from this idea of cumulative cultural evolution, trying to apply kind of evolutionary models to how culture grows, that like complex culture, like, things like evolution of technological complexity, it starts with simple tools, and over many, many failures and iterations, like we build up technological complexity. And also this is relevant in the evolution of large-scale cooperation amongst human beings. Many other animals also cooperate, but like we are the one animal that like can collaborate across the planet at like severe scales. Like so, telecommunications is like the next frontier that enables us to evolve in this cumulative cultural, cumulatively evolve our cultural DNA, let's say. Similar to the genetic evolution, which is much, much slower. And like genetically, we are not that much different from our apes, the nearest ape, but like culturally, because of these kind of cumulative evolutionary models, we are significantly much better off. Again, it's not something that I'm making up. Like a lot of evolutionary theorists have like kind of spoken about this idea of borrowing Darwin's idea and applying it to cultural evolution, including very recently Noah Harari, and who wrote this best-selling book about the brief history of mankind. So cumulative for us kind of means historically like not to disrupt. Not many people might associate Zaidi, the architects, with any interest in history. Actually, we're completely the opposite. We have like a deep history and interest in history. For example, it could be just referring to other disciplines like product design and photography and so on. So Euro Kokopora, like for example, like he designed the less famous Vitra chair. Like Eames is obviously the most famous one, but this also sells for pretty much the same amount. But you know, like these furniture designers also like they translate their language and geometries from furniture and transcend it to buildings. This is his office in Finland. Historically, we are also very much interested in like evolution of geometric complexity, tools of geometric thinking, which sometimes leads us all the way back to the French and their fancy pants. It also takes us through Bauhaus, even though it was a very short period of like maybe 15 years. Like we believe that they delivered like a lot of seminal research and things that we want to reconnect with and bring to the 21st century, because they made significant progress, which unfortunately due to the wars or whatnot, like kind of got disrupted. Again, another like seminal hero and shiro for us like is Ray and Charles Eames, like, and their legendary career over 80 years. Not only in like the cleverness they had towards material, like they borrowed a patent or they bought a patent from the U.S. Army. They also bought the machines, and this is their living room. Before they started designing for that machine, using that machine, and expressing the qualities of the material through the machine. They also invested heavily in like collaborating with like early software makers, like this mathematical software, and so on and so forth. So that's the general context from which like we operate our research, and mostly what we focus on, what I will try to focus on now is this distinction between production on the one hand, where we as architects have like our internal discourses and like theory and like so on and so forth, and understanding of new technologies of design and construction. And likewise, how we can begin to understand how people actually use our spaces. And because people normally don't care for our theory, they don't care for how we actually come up with the design, but like they do fundamentally care about like their user experience, and how the building is the user interface to that experience, or in other words, how architecture is consumed. So I will end the talk with like a little bit of our current focus on the consumption side, but most of the talk is on like our research on making efficient production. So in that sense, it's a specific strand of collaborative and cumulative design research, specifically in digital design and fabrication, which is machine augmenting of human designers and machine augmenting of human labor in construction. So we're calling this, we as like Patrick Schumacher kind of gave this a name, even though it's going on for 10 years. Last year he called it tectonism. And very simplistically, like it is not anything more than stylistically heightening the engineering and fabrication-based form finding and optimization processes. That's a mouthful. The simpler version is making visible in shape its structural, its fabrication, its environmental performance, meaning making its performance consumable by visually. So to try and make it visible, its own rationalities, whether it's structural or social or any of the other aspects that go into its making. Maybe it could be visually seen in some images like these, where like the lines of the roof, those are expressive of the natural way forces flow through these curved shapes, and therefore you can also put lights parallel to the lines of force. But also it helps people guide their eye and navigate through the space by following these kind of structural logics, but they become visible and help people consume this, understand it, let's say, viscerally. And I'm going to talk about like 3 specific research strands as examples of this. One is related to fabric structures, like how these geometries already when we are designing with it, know how they will be made. For example, in this case, fabric structures. That's why we're calling it fabrication-aware geometry, meaning it's not arbitrary complex shapes, but they're shapes that are easier to make and efficient in their structural performance. If I have time, I will talk about like similar fabrication-aware geometry in folding of metal. And I'll also talk about like similar fabrication-aware geometry in 3D printing of plastic and also 3D printing of concrete. And finally, I will give this exemplar. This is the current state of our research as manifested in a building. That is a commercially procured building, and this is a gallery for mathematics. It's only 1,000 square meters. But we think this is the current state of our research. Like we hope and we believe we are at the cusp of being disruptive, meaning we are at the cusp of becoming mainstream, or we are making every effort to deliver our revolutionary gains to apply to as many buildings as we possibly can, and therefore try and make it as mainstream as possible. So starting with shell structures or fabric structures, that just to give you a breadth of the kind of research and collaboration and cumulative ways we build up this research over 4 or 5 years. So, for example, many of the ideas start with work with students. This is like a workshop we did with students at the DRL several years ago by plaster casting into fabric molds, and then assembling these pieces into a larger shell, let's say. That wasn't the successful part, but like the casting was indeed quite a revealing of like how plaster flows through these kind of fabric forms. In 2010, we took that idea and like in Bangalore, like over a 10-day period, like with students and like local, with my colleagues from the team, and also local help like from my father's office, and also students and labor from Bangalore, we were able to use this idea of stretching fabric to describe the shape. So we didn't have any drawings, like we just knew how to cut the fabric and stretch it up, and it naturally describes the shape, and it also becomes the guide work along which to lay the reinforcement. Again, we didn't have any drawings for the reinforcement. We just told the labor force to say, divide the pipe along the border equally and like take the steepest path down. And you can see there's a kind of rationality to that, like, so some lines stop and others continue. And if you were to do a structural analysis, this would come very close to a kind of optimal reinforcement layout for this kind of geometries. We took this idea also, we did a similar exercise in 2011 in Mexico City. Anecdotally, the building in the background is from Legoretta, and he famously hates any curves. So we thought like he deserved some curves in his campus. Again, we did this with some students and like local labor force over 10 days. Similar ideas of making the shape and then casting concrete onto it. Another kind of exercise with students and local construction labor force and local technologies and local craft in Mexico City again. And here the holes are not arbitrary. We have removed material from the shape that does not do anything in the sense that it's not structurally performing. So the shape is highlighting all the areas where there is no material, that material is actually not needed to carry the forces. So this, with like almost 30 to 40% reduction of material, has the same strength as if it were completely solid. So whilst we do these kind of prototyping physical exercises to build our intuition and geometric ideas, we are also working with the Block Research Group who are developing contemporary computational technologies to help understand structural behavior in a geometric sense, not in a numerical calculation sense, but in this intuitive force flow idea that can be calculated using purely geometric principles, not numerical calculations, as is usually the case in engineering fields. But these are very design-relevant technologies because it gives us an intuition of how these kind of complex structures actually stand up. In this case, everything is held together by a single wire that goes around the perimeter, so as soon as you cut it, everything falls down. So that makes it very intuitive, for example. So we've been working with their digital tools and extending them to marrying them with our kind of design ideas and contributing our own computational expertise and like writing our own code to extend their toolkits to make them amenable to our aesthetic. To design these kind of seemingly complex shapes or seemingly unnecessarily complex shapes. But what is beautiful about this is literally what works at this scale can be kind of scaled up, and you can, if it stands up at the model scale, it kind of highlights that there is no glue. And if it does stand up, you can kind of scale it up to work in concrete or with stone. So it's like a kind of geometric principles that like people like Gaudi and others, even like the St. Paul's Cathedral in London, used to use prior to the invention of numerical calculation in the 19th century. So we, as I said, like our interest is not only like developing these technologies, but like to look at like the implications on shape. How do we express these things? Utilize these kind of tools to express the possible shapes, and therefore, as designers, we are kind of like picking and choosing and guiding the machine towards certain outcomes. So you can see a range of studies like which look all similar, but like they're variations of the same theme that can be quickly produced because of this algorithmic way of exploring what might be called the space of all possibilities. So we've been trying to marry like this historic masonry logic, a brick construction or stone construction, with our aesthetic of like fluid curves. So far, we have not found a client to build this yet, but like sooner or later, we hope that like this kind of compression-only thing can be manifested in stone in the near future. But so we are kind of confident at this stage that like this can be built in a kind of very masonry way, in a very low-tech way, if you will, in a historically relevant way, which most cultures have this kind of skill to do masonry. So it doesn't need to be in concrete. You don't need formwork. You can like kind of do it in by just adding this computational sauce to historic knowledge. So I will try and skip through this part, like rather quickly, but another topic that that we research a lot in a similar sense to the shell structures is this idea of curved origami, where the fold lines are not straight lines, they're curved. And again, a lot of this is historically, knowledge is historically present, like starting not only in the 12th century, but kind of revived in the Bauhaus in the 1930s by Joseph Albers, and also now contemporarily renewed by mathematicians like Eric and Marty Demain at MIT. So what we find interesting about this domain of research is that mathematicians like David Huffman, on the person with the beard, oh no, both of them have beards, the bigger face, the one on my right, he's a mathematician, but he also equally contributes as much as Ron Resch, who has a more artistic background. And these kind of domains like really interest us, where there's mathematics, but there's also artistic exploration of the same kind of principles of finding shape that are relevant. And there's also increasing interest in new set of computational technologies that allow you to recreate these kind of simple shapes of folding digitally. You don't have to fold it in physical paper. And we also explore the design side of it by making many models. So what's pleasurable about this, you only do the 2D pattern and then just fold. And within like a couple of days, like you can generate a whole range of explorations, and you really intuitively understand how the material is behaving and how the curves that you're drawing is lending it the shape. So it's like a bidirectional relationship between what you draw and what you get, and changing what you draw to change what you get. So for example, all of this, it comes from one single flat sheet of plastic, which we just laser cut or laser score, and like you just fold, and you get curvature in a way for free. And what it also adds is like all these seams adds lots of structural strength. So it's flat sheet material. It can be paper, it can be plastic, it can be sheet metal. So it can be easily formed, and the only tool you need is a laser cutter. And many times you don't even need that; you can do it by hand. Like most of these, like kind of produced with very little, very low tech machinery. And it carries like a one person's weight, and it's literally 20 pounds to make one of these things, because it's a sheet of plastic. So the physical shape finding is very intuitive. Like as I said, like you just score paper, and then you fold, and you get curvature for free, but you also get variation for free, because you have to just repeat this process. So complex shapes are formed very simply. And so we did this in Bangalore with students, again, over four hours each. Each of these eggs took 4 hours. And so, like, again, it's very low-tech ways, and so it can be equally applicable whether it's in Germany or in Mexico or wherever. Like, all you need is like some cleverness geometrically. So we've been researching how to capture all of these kind of material intuition digitally as well. And we've been building prototypes using this kind of physical ways of form finding and developing digital tools to enable this kind of complexity. So this is the state of curved origami research. And lastly, 3D printing research I'm going to briefly talk about like our interest in machines and how machines begin to give us new expressive capacities. For example, you start with a very simple robot, try to get it to do some simple things before, try to get it to do the foxtrot before it can do the salsa kind of. And what we get out of that are these kind of expressive qualities, like which is very difficult to model digitally, and it's very difficult to imagine like how you would conceive of these shapes. But like all these textures come by just stopping the machine for 1 second more, or like perturbing or deviating the path of the robot like slightly. So these kind of expressive aspects of material and the combination of machines is what really interests us in. So again, it's so intuitive that like students can do this like over a weekend. They built the extruder and all of this, and like we just supply the robot, and it's a very different way of collaboratively exploring the universe of possibilities between material, between machine, and between you as a designer. So since I'm like rather short on time, I'm gonna try and skip through a few how this we think is scalable. Again, relates to history in the sense that like 3D printing can be assumed or can be thought of as a kind of scaling down of bricks at one scale. Like if you scale it down and make it micro bricks, you can intuitively understand 3D printing. And so that's what we're doing now, like developing software on the basis of this intuition that masonry can be really scaled down, and we can still understand all these complex shapes the same way we understand brickwork. And this is the current state of it, like through our industrial partners, like these kind of column formworks can be built up in a matter of few hours, and rather than few days. So to skip to the conclusions, like what we're trying to say is that like this is the current state of research. This is from ICD Stuttgart. Like every year they get closer and closer to becoming mainstream, and they're passing regulation. They're overcoming like technological hurdles, and likewise at ETH Zurich, like they're overcoming a lot of computational hurdles and machine hurdles to bring these kind of technologies to as close to mainstream as possible. And like, so we believe our project is therefore in a similar vein. While the industry is doing research, is doing that, like we are trying to contribute to that party by like making use of some of these technologies to deliver projects like these, which is the Gallery for Mathematics at the Science Museum in London. And you can see it involves a lot of intuitive processes about shape. Like we need to feel comfortable about like all the complex shapes because we have done the prior research. Like we know how to make it physically, we know how it behaves, we know how to make the pipes, we know how to tailor the fabric, and so on and so forth. So it's a kind of cumulative, collaborative endeavor, which we believe like in the next few years is gonna yield a lot of mainstream results. Like, so I don't have time to go through our current set of projects that are leveraging these kind of technologies, but I will leave that to your imagination. But you can these images already kind of tell you the levels of control that, like, in a very short span of time, like 4 or 5 years, like we start from simple experiments with students, and we are able to manage very, very tight tolerances, very tight budgets, time budgets, very tight financial budgets, and to then allow architecture to focus on the user experience and the objects themselves, because this is a gallery. Because all the technological complexity was kind of hidden away, we were able to develop and tools to position these objects. Every Monday morning, we would get a new list of objects. So we had to develop these automated ways to position the objects, change the layout, send it back to the curator, and he would be like, no, like change that, change this, and so on and so forth. So when technology is sinking towards the background, allows us to focus on the storytelling, it allows us to focus on the user experience. That's why we believe that like this method of cumulative research-based practice and practice-based research is really like the kind of way forward for us, which is machine augmented, but it is eventually in the service of humans. For example, like we are able to devote enough time to understand what is the depth of field, like what can people see, what can they experience, like through various parts of the gallery. And since its opening in December 2016, by December 2017, already 1.1 million visitors had passed through this small gallery, which prior to that hardly anyone used to go through this gallery for mathematics. So I will leave you with a set of videos that kind of show further other projects. So thank you very much. Yep. Oh, okay. It's fine. If people are patient enough to watch the video, I can play it.
Can we get the video to play, please?
Since we like images, if you want to know more, you can go on our Instagram. Yeah. Thank you. So.
Okay, while this plays out, ladies and gentlemen, this draws us to a conclusion of India Arc Dialogue 2018. I'd like to thank, first of all of you for being such a wonderfully engaged audience. We've had a great turnout on all 4 days, for which we feel very, very happy. I'd like to personally thank my co-curators, the team at FCDI, and all the wonderful speakers who have come from all over the world to come and share their ideas and their thoughts with us over these 2 days, over these 2 weekends. All that remains for me to say is that the exhibition continues until the 25th. Do please tell your families and friends to come and to see it. There is also an email on which we would await your responses, your feedback, good and bad, on what you've seen over the past month, or will be seeing in this month of February. And that's it. So thank you all, and have a safe trip home. Thank you very much.